All right, living environment friends, fanatics from across the globe, worldwide, and here in Peru, the beautiful town of Peru. It's Wednesday. You know what that means? We've got book talk. We haven't had a book talk in a while, right? Haven't had one since before the break. We started a new book. We started this book called Stiff by Mary Roach, which is all about what are things that are done with dead bodies. And I think you really dig it. The first chapter, of course, talks about like cosmetology school, and it's really kind of graphic and kind of icky and gross and perfect for ninth grade reading fun. So let's do today's Bellringer. They've got an ed puzzle lesson. We're talking more about genetic engineering, and then book talk. That's what's on our agenda today. All right. Hey now.
Mr. Kovacs class. It's Mr. Kovacs class.
You might learn a ton.
It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
Andy's super cool.
It's Mr. Kovacs class.
The monkey that's really fun. That's Andy. That's Andy. Who's the monkey who's number one? That's Andy. That's Andy. Who's the monkey that's really keen? That's Andy. That's Andy. Who's the monkey with the jellyfish gene? That's Andy. Andy. Yeah, we learned about Andy. Andy the monkey. There he is. Little monkey, but we remember that Andy the monkey is a special kind of monkey because he also inherited a gene from a jellyfish, which is weird for monkeys. What's really weirder is that even though he's got this inherited a gene from jellyfish, he can't swim. Weird. Anyway, let's talk more about genetic engineering and genetically modified organisms.
There's the cute little guy, Andy the monkey, and yeah, remember the old-fashioned way, right? You'd have egg made by mommy monkey, sperm made by daddy monkey, and sperm meets egg, and you wind up with a new cell that's got all of the genes to be a monkey, and that cell will copy itself over and over and over again until it grows into a monkey. Hey, yeah, that's what happens. Of course, Andy is a little bit different. He did have a mommy who made an egg. He did have a daddy who made sperm cells, but they put one gene from a jellyfish genome, and it happened to be a gene that glows in the dark, right? And so we know that Andy the monkey, unlike most monkeys, can glow in the dark. Fingernails, hair, all that stuff. But how'd they do that? They wound up cutting out the gene that from the jellyfish, right, and inserting it into a virus. And we know how viruses work. Viruses infect cells, right? So you basically swap out the virus DNA for this protein that glows in the dark DNA, and then you infect the egg with the virus. Then you fertilize the egg, let mom carry the baby, and then she gives birth to a genetically modified monkey, Andy, right? Andy the monkey. Look at the cute little. So what does this mean? This means a couple things, right? It shows that monkeys can copy jellyfish DNA. How do we know that? Because now that he's grown up as a monkey, you can see he glows. So he can also read jellyfish DNA, even though he's a monkey, because he glows. Even though he can't swim, he still has jellyfish DNA because he glows. If he were to have children of his own, there's a chance he would pass on the gene for glowing in the dark, right? And if it was an advantage to glow in the dark, he'd be more likely to pass on the genes for glowing in the dark. And we're getting ahead of ourselves, but that's what we're headed towards, right? How do genes change amongst populations? Well, you have to be a change, and then they have to stick, and that's how that works. So we'll get into that later. Andy the monkey. Cutting out the gene requires using what are called restriction enzymes. So restriction enzymes are enzymes that cut deep pieces of DNA at specific segments, specific sequences, right? And so they're used to cut out the gene that you want from the jellyfish, right? And then put it in a virus, and then the virus will incorporate that recombinant DNA into the monkey's genome. Now, this is how we do lots of things like this, where we switch genes from one organism to the other. Like anybody who's got diabetes, right? They need insulin. Well, if you can't make insulin, you need to go to the pharmacy and buy it. Well, the pharmacy, it's not like they're milking people for pancreases for insulin. right? Pharmacy gets it from companies who basically enslave bacteria by cutting out the piece of DNA, the human DNA, to make insulin and inserting it into the bacteria. The bacteria can copy that DNA. The bacteria can read that DNA and make human insulin. They'll pump it out of their bodies, and then you collect it, put it in a bottle, and you save somebody's life. It's amazing, and it's awesome. And it's all because of the technology of genetic engineering, like Andy the monkey. That's me. Yeah,
That's
Andy.
really nice. That's Andy. That's Andy. Who's the monkey that gives good advice? That's Andy. That's Andy. Who's the monkey that's really cool? That's Andy. That's Andy. Who's the monkey that you know is gonna rule? That's me. I'm Andy.